Hello friends, today we are going to solve this integral over here, that is e to the power x into 1 plus x divided by x e to the power x into x e to the power x plus 1 into d of x. Now when I look at this integral over here, it seems very difficult to solve this integral easily. But we can solve this integral easily by using use substitution method. Now see that when I look at this term x e to the power x, and if I take the derivative of this term, what I will get e to the power x into 1 plus x. Now from here, one thing in my mind is that I need to take u as x e to the power x. So I will take my u as x e to the power x. As you all know that we have to take the derivative of this u over x. So that means we are taking the derivative of x e to the power x with respect to x. As x and e to the power x are simply in multiplication form, that means we have to apply the differentiation or derivative product rule in this form. That is simply u into v derivative plus v into u derivative. You have to take the derivative of x first, keep e to the power x as it is, and you have to take the derivative of ex and keep this x as it is. So this is really simple. If I am taking the derivative of this u with respect to x, then du over dx is simply equal to x e to the power x. I am taking the derivative of x first, e to the power x first. Now I am taking the derivative of x, then the derivative of x is simply 1, so I will get e to the power x. So du over dx, if I take e to the power x as common from this, e to the power x into x plus 1. So that means that this du is simply equal to e to the power x into 1 plus x. I can shift this 1 and x, and this is into d of x. Now see over here that this e to the power x into 1 plus x into d of x, e to the power x 1 plus x into d of x in this integral over here is simply equal to d of u. Now you just need to do what you need to do is simply you just need to substitute the values of du u over here in this integral. Now if I substitute the values in this integral, what simply I will get is I will get integral of 1 divided by u into u plus 1 into d of u. So now see that I simply have to take the integral of this 1 divided by u into u plus 1 into d of u. So if I separate this u into u plus 1, what I will get is 1 divided by u into d of u minus integral of 1 divided by u plus 1 into d of u. Now see that if you solve this over here, 1 divided by u minus 1 divided by u plus 1, you will end up getting at 1 divided by u plus 1. You can try this and verify this. If I take the integral of this 1 over u, what I am getting natural log ln into u minus, if I take the integral of this u plus 1 as the derivative of u plus 1 is simply 1 over here, that is in the numerator. So that means this is also the natural log, that means ln into u plus 1 plus c, the constant that we always add when we have an open interval. So by the laws of logarithm, I can write this as ln into u divided by u plus 1 plus c. So this is what you answer over here. Now if we want to go into the depth of this integral, I can say that, I can simply note that this u is simply equal to x e to the power x. Just substitute the values over here, x e to the power x divided by x e to the power x plus 1 plus c. Now see that this x e to the power x over here is simply greater than minus 1 for every x, for all x. So that means we can write this as log x minus log into x e to the power x plus 1 plus c. Or you can write this as natural log ln into x minus x. This is simply how it works. So now if I convert this into this form again, then I can write this as ln into x e to the power x. This is simply in your x e to the power x plus 1 plus c, that constant. This is how it works. This is also your answer if you go into the depth. This is also your answer if you don't want to go into the depth. This is how you solve such integrals.